Man, I might be able to get something done if I didn't have all this red tape to go through. Y'all get it. Alright guys and gals, this was going to be a single video, kind of divided into two parts. But I've had some trials and tribulations. Stuff hadn't gone as smooth as I thought it would, so figured I'd just make this its own video. The one video was going to be it was going to be what's going in this space here, as I've alluded to in other videos. And then the first part was going to be about just kind of briefly showing me getting the electricity here. But like I said, that's gone a little slower and tougher than I thought, so figured I'd document all of it and make it its own video. So I'll get into kind of the problems I've had and what I've had to do to overcome them, and yeah, stuff like that. So let's get into it. So the project starts here at the meter where the power comes into the well house, which is that block building there in the background. Previously, somebody had used some submersible well wire to come from the meter into the panel inside the building, and it was only like 6-gauge wire or so. And for the project I'm doing, I'm going to need bigger wire for that to carry more current. So I went with 1-gauge wire and 4 of them because this is 3-phase service, and I'll get to that later in the video. Now on the other side of the building, we're starting to dig our ditch to bury the conduit. And the new power is going to come out of the hole there near the corner. And we get going on the way, and as you can see, I'd already dug a ditch coming the other way under the fence, so I wouldn't have to hand dig any. And that did present a bit of a problem, which you'll see here in a second. And here we're getting rolling the other way across the fence. As you can see there in the background, we got a dust storm rolling in. We get a few of those with our dry and windy conditions. And then here you can see the problem with overlapping. I have to hand dig all that loose dirt out of there, which is no fun. Got pretty exhausting. Now that the ditch is all dug, now I can start stringing all my wires out, and they're on these spools, so I figured I could use the 3-point system on the tractor to lift them up, and that would allow them to spin. I used a piece of 3/4 inch pipe to go through the eyelets on the lift arms and just lift it up to the height that I want. Once that's set, then it's time to start walking and pulling. So with 3-phase service, I'll have the 4 conductor wires, and without steel conduit, I have to have a ground wire. So I have to make 5 trips down and back that whole way. I got pretty exhausted there at the end. So this is probably the biggest problem I had on the whole job. That far of a distance, there was no way I was going to be able to pull the wires through the conduit, just having one person on the job. So I was sliding the conduit over the wires that whole distance, and I tried doing it by hand. Those are the first 2 joints I did, glued them together. Now I'm going back, running all the wires through my hand, trying to keep them in a straight line bundled together, so there's not as much resistance when I come back with the next piece of conduit. And this is my second trip, and I'm just about gave out. My legs are gave out already. Not much energy left, and that was only 2 trips. And here I am, done decided I've got to come up with something better. This is not sustainable. I'm already gave out. So I dreamed up an idea to make this a little easier. One problem I was having was slack in the wires pushing in front of the conduit as I was trying to slide it over. So I taped all the wires together, taped on my wire around the ground cable because it was quite a bit longer. Then I used that extra length to tie to a come along, which was tied to a post, and that way I could put tension on the wire and prevent slack from pushing up in front of me. And my new method was to glue 2 pieces of pipe together and slip them over the wires, and then put tension on all the wires, and then use the winch from a Polaris Ranger to actually pull the conduit over the wires instead of me doing it all by hand. And having thought of this solution and being kind of proud of myself, this is about where I decided to make this its own video, and this is where I started documenting everything I did, so y'all enjoy. So I've made it about 180 feet so far, almost halfway, but I came back here to the source. I'm gonna go ahead and try to put from there back in the ground, just so I can go ahead and make sure I got enough sticking out, and then get everything inside the building buttoned up and tied in. So let's do it. Well, got that small section in the ground, and we're inside the building. Got it all clamped up and level and everything, ready to fill the dirt. Wires are in the box, ready to be hooked up. Going to this breaker. But it's a beautiful day out, so I'm gonna use the nice weather and go ahead and finish running the conduit over the wires so I can have that done. Then maybe I can use the ditcher to fill back before I gotta return it tomorrow. So let's get to it. All right, here we are gonna hook up all the lines that we just ran and put in the ground. This will be the panel supplying the power. There, the main breaker is off, so there's no power in here. No worries about that. This is all I like at this end, so gonna go ahead and knock this out so I can get all my tools picked up and get the area cleaned up, and I can be done with this end of it and I can concentrate on the other end. So let's get to it.
done.
All right, we're back the next day. Last y'all saw, I was putting the conduit in the ditch. So since then, I got the wire and conduit stubbed out of the ground. Got a frame welded together to mount the panel to. Got the panel mounted. And now we're ready to hook the wires up, and then we'll test everything, make sure it's all good, and then I'll cover the ditch. So let's get to hooking it up. Man, I might be able to get something done if I didn't have all this red tape to go through. Y'all get it. Well, there she is. Got the final hookup done. It's nice and clean in there right now, in my opinion. And forgot to mention in the previous clip, but I made sure and put in an expansion joint right here. So this piece here can slide up and down. And that's the purpose of that is for when the soil settles and everything, you know, the stub coming out of the ground may move around a little bit, and if that's all rigid, then, you know, something's liable to break. So anyway, now that we got that done, time to test it out. Let's go back down there to the source and flip the breaker on and come back and test voltage. Alright, hopefully y'all can hear me alright. The wind's whipping pretty good out here, but got y'all a good look at the inside of this panel. Figured I need to explain a couple things first. This is a three-phase service that I brought over here. So for anybody who doesn't know, like your service for like your house or anything, not running a bunch of heavy machinery or anything like that's going to be considered single phase. Out coming off your power pole, you're going to have one transformer, and you're going to have these right here are lines. So like this would be line 1, line 2, and on this system line 3. Your residential single phase will only have 2 lines coming in, and that's the power coming in. And most of the time each one will be 120 volts. So this system being 3-phase, we got 3 lines coming in. Line 1, 2, 3, like I just said. This one over here with the white tape is neutral. And this 3-phase is a little bit different. It's has a high leg, or there's a lot of nicknames for it. From my research that I've done, the reason for the high leg system is it's a way for them to give you 3-phase service only using 2 transformers out at the pole. And as the name indicates, it's high leg because it has a higher voltage than the other phases. But when you do phase to phase voltage, it's all going to be the same. So just for reference, at the source where we just flipped the breaker on, phase A was running 124 volts, phase B 124 volts, and then phase C was going to be at the source. It was 218 volts. That's the high leg. That's why I marked it with red tape. So with the breaker on, now we're going to test it. We're going to do each phase to ground to see what we got. Hopefully y'all can see the voltmeter over here. Phase A to ground, 124. Phase B to ground, 124. Now the high leg, phase 3 to ground, 218. So the same as it is at the source panel. So that's good. Everything is good. Now I can cover up the ditch. But like I was saying, if we go phase to phase, see, we get 251. Phase A to phase C, 252. Phase B to phase C, 252. So I think that, I am no means an electrician, but I think that would be considered a 240 volt system. For whatever reason, it's just running a little bit high. And if you go from phase to neutral, it's all going to be the same. Get my hand out of the way. So yeah, everything checks out and good to go. So for any of y'all watching with a eye for detail, y'all may have noticed this right here, and you probably know why. So that's a splice connector, because my wires were too short. I'm known for cutting things too tight, too close to margins, not giving myself enough room for error, and that's what happened there. So I had to splice on about a foot piece. I hated that, but I could have moved the panel back a foot and been good, but this is where I wanted it. So in that one with the red tape, it was barely long enough. That's why it's tied around that corner. Didn't have any real slack like the other two. So dadgummit. Yeah, now everything checks out good. Now I can fill in the ditch, but I'm not going to show y'all that because it's pretty self-explanatory. And y'all may be wondering why I ran power all that way, almost 400 feet. I think it was, I don't know, 370, 380, somewhere in there. And one issue with that is running electricity a long ways. You're going to have voltage drop, so you have to upsize your wire. You have to get a larger conductor. So if I understand it correctly, you have to, when you use a bigger conductor going along, a longer distance, that gives you a cushion, gives you an allowable voltage drop for the appliance that you're trying to power. So like I ran this over here, the appliance is going to be on a 25 amp circuit. So the source I used online, the calculation said I would have needed, I think, 4 gauge wire, I think, to come this far. If I wasn't going a long distance, it would have just been 10 gauge wire, 10 or 8. But I didn't go with 4. I went with 1 gauge or 1/0 because I hate limiting myself in whatever I do, like stuff like this. So if I would have just ran 4 gauge, then I could have only run that one appliance that I'm going to be hooking up, and I couldn't have run anything else. Now, I don't foresee powering anything else over here, but the thing is, you never know. And now I have the option to be able to run something, or 2 or 3 other things. Running that bigger wire, I was able to preserve, this is a 125 amp panel. It's on a 100 amp breaker. I think I can run close to that full 100 amps with that size of wire coming this far. So that's my reasoning for using the bigger wire and not just going with the 4 gauge. So y'all may be wondering what I'm going to be putting here, or you might not, but This is a blank spot now, but not for long. If y'all watched one of my previous videos, I hinted that what's going there is I'm pretty excited about. Looking forward to it. But I'm not going to tell you. I'm going to save that for its own separate video. So as y'all saw, I had some obstacles to overcome. It was some hard work. I had to get kind of ingenuitive, figure out how to do it, being only one person. So if anybody's out there watching and they think, you know, I should have done it different, or there's something I could have done to make it easier, or if I did something wrong, which I'm sure there is, y'all let me know down in the comments, and you know, that way I can learn something. So I hope y'all found something interesting in this video. Maybe I helped you do something, I don't know. But if y'all stuck around, watched to the very end, thank you very much, and hope to see y'all on the next one.